In this video, we're going to look at long division of polynomials and the factor and remainder theorem. And we're going to touch on synthetic division also in the end, because it's a little bit easier if you're dividing by x plus or minus a constant. So we'll touch on that at the end, but long division works for everything here, so we're going to go over long division first. So the first thing we're going to do is divide two polynomials. So in this division process, we use long division, which is where we take our polynomial that we're dividing into by the polynomial we're dividing by. We're going to write it as a long division, meaning that this part here is going to divide into this part here. Now, I'm leaving a little space here because there's a missing term here. An x to the second power is missing, so I'm going to just add a little term for that. Usually I'll just put a 0x squared here, so now I have 3, 2, 1, no powers. So when we're dividing it, you may end up having a term that you have to align up here to that term, so it's nice to put the 0 in there. This goes 2, 1, 0, so we don't have to have a term there, and we're dividing by it anyway. Alright, so what we do in long division is we look to see how many times this initial term, factor, this term here divides into this term, the first term here. So we're dividing those two terms. So we're taking a look at 2x cubed divided by the lead term here, x squared. And when we do that, that gives us 2x. So that's what our first term is going to be, 2x. It has to, basically what we're going to do then is multiply this times everything in here and write it underneath and subtract. So we want to get rid of this first term. So when we multiply 2x times x squared, we get 2x cubed. And if we subtract those two terms, they reduce to 0. 2x times x is going to be 2x squared. That's another reason I left it there. And then 2x times 1 is 2x. Okay, now what we're going to do here is we subtract this. So this term is subtracted. And we write down what we have left over below. So these drop out. We have negative 2x squared, because it changes, it's 0 minus 2. A negative 1x minus 2x is negative 3x. And then this one doesn't have anything to subtract from, so there's a plus 1 there. So this is what the polynomial is left over after we divide by 2x. Now we're going to divide 2x into this one. So we're going to do that. So negative 2x squared, that's the lead term that's left over, divided by x squared, that's the lead term on that one we're dividing by. We get negative 2. So that's what goes up here, negative 2. Now we multiply that by all three of those terms. If there's two terms, we only multiply by two terms, but in this case we're multiplying by three terms. Negative 2 times x squared, negative 2x squared. Negative 2 times x, negative 2x. Negative 2 times 1, negative 2. Alright, we subtract that from the previous one. These drop out. That was our goal, to reduce down, keep reducing. This minus this changes this sign to plus, so it'd be negative 1x. And this changes this to plus, so that would be plus 3. Now this term doesn't divide into x, so this is our remainder in this division. So when we write this, we write the answer to be, when we divide here, the answer to this is 2x minus 2 plus a negative x plus 3 over this x squared plus x plus 1. This is our remainder. So this is our answer when we divide. It might also ask just to type in the remainder without the denominator. That's how we would do that. Okay, let's take a look at another example. Down here, another example of a division problem, and practice long division. So starting off with x squared minus 1 divided into 4x squared minus x minus 23. We don't have to do anything there. All right, so we would divide the first two terms. You have the 4x squared divided by x squared here. So if we take the 4x squared divided by x squared, we get 4, so that's our first term. Okay, we're going to multiply this by those two terms. We get 4x squared minus 4. Well, we wouldn't put that under the x, we'd put it under here, minus 4, because it's matching. We subtract. This goes away. This has a 0 here, there's nothing here, so it's going to be minus x. And then this changes to positive, so that's going to be negative 19, actually. Now x squared doesn't go into x, this power is less, so that's our remainder. So this stops right here. This is going to be equal to 4 plus negative x minus 19 over x squared minus 1. That will be our answer in that division. Now, that is long division. We have to break that down and subtract each time and use what's left over each time to divide again. All right. Next is the remainder theorem. The remainder theorem says that if you divide by x minus c, a constant, plus then the remainder is just when you plug in the value of c into the function. So what we're saying here is we don't need to actually do the long division here. If it asks you, for example, to find the remainder of this division, we know that here, if this is x minus c, that equals x plus 2. C is going to be negative 2. So that if we take our function for x squared minus 3x minus 1 and we plug in our negative 2 in for x, 4 times negative 2 squared plus or minus 3 times negative 2 minus 1, that's going to be our remainder. So this is 416 plus 6 minus 1, so 22 minus 21 is our remainder in this problem. Okay, so the remainder of this is 21. All we had to do is figure out what c was and plug it into this divisor, or the part that we're dividing into. Okay, so that's helpful, so we don't have to do long division. Now the factor theorem says that the polynomial, if it's a polynomial, p of x, then c is a 0 means if and only if x minus c is a factor. So if we know 1 is a 0, then we know it's also a factor. So in this example, we're given that c is a 0, and we want to find the other two zeros because it has 3 because of the x cubed here. So what we would do is, since we know that this is a 0, then we know that x minus 1/2 is a factor. So we can divide by x minus 1/2. Okay, so we can divide by x minus 1/2. So if we do that long division wise, x minus 1/2 divided into 2x cubed minus 3x squared minus 11x plus 6, we should get something that comes out nice and even, which is a quadratic, which we'll try to factor or use the quadratic formula on to solve. So if we take this x and divide it into that, that's going to be 2x squared. 2x squared times that is 2x cubed. 2x times a negative 1/2, we have to multiply by both of these, is going to be x squared. Alright, we're going to subtract. Get rid of that. This is going to be minus, so that's going to be minus 4x squared. We have these two remaining terms, minus 11x plus 6. We're going to divide again by x. So x goes into this, minus 4x Okay, so minus 4x times those things is going to be minus 4x squared. A half times that is going to be positive 2x. We're going to subtract. Goes away. It's going to be minus 13x plus 6. Okay. Then we need to divide this into this, so it's going to be minus 13. That's not a factor. Let's check to see if it's a factor. If we say it's a factor that goes in there, it should be 0. So let's just double check, because this is not working out here. Because then when I divide this, this has got to be negative 13. So negative 13x, then half of 13 is a positive 6.5. So we're off by a half. So something went wrong here. It's not a factor. And if it's not a factor, we can't find the other two factors. So let's just double check this, because I took this from a problem, 2x cubed. All right, minus 11x is 3x squared, 2x cubed. All right, let's just double check to see if it's a factor, because it doesn't say, it says given it's a 0, that means it's supposed to work. So let's try it, the other theorem that says if we have 2x cubed minus 3x squared minus 11x plus 6, and we know that 1/2 works, that means 1/2 going in there, 2 times 1/2 cubed minus 3 times 1/2 squared minus 11 times 1/2 plus 6 must equal 0. Let's just double check. This is 1/8 times 2, so that's 1/4. So let's just, oops, sorry. We're going to check this out. That's 1/4. This is 1/4, so that's 3/4 minus 3/4. Okay, minus this is 11 halves, so that's 11 halves plus 6. So this minus this is minus 1/2 minus 11 halves plus 6. So that's 2 halves, 2/4. That's right. So this is 0. Minus this is minus 12 halves, which is 6. All right, so what did we do wrong here? Okay, we got that right. They copied down the sign wrong. Okay, let's see. 2 times this is 2. 2 times that is negative 1. Oh, there's where I made a mistake. Okay, so I found my mistake. It's right here. This mistake right here. So this is negative. So that's changed to positive. Then that's going to make this, we're going to have to erase because I made a mistake. So here from this point on is a mistake. So let's get this out of the way and start over. Okay, so we have minus there, so I made a mistake on the sign here. So minus, that's positive, so that's negative 2x squared minus 11x plus 6. So hopefully now this is going to be different. Okay. Let's check that out. So now that's going to be minus 2x. Okay, so minus 2x. Okay, this times that is going to be positive x. So we're going to subtract that. It's going to go away. That's going to be minus 12x plus 6, and that's going to work out. All right, great. Because then that's going to be a minus 12. So minus 12x, and then half of that is positive 6, and we subtract, and we get 0. So that works out. So here's my other factor. So that's what I would need to simplify to get my other two zeros. So I think I can factor that to get the answer. So if I take out a 2, That's x squared minus x minus 6. I believe I can factor this. And we're setting it equal to 0 to find the answers. X and x minus 3 and plus 2 equals 0. So that's going to give us negative, that adds up to -1 and multiplies together. So this thing right here is going to be 3. 3 minus 3 is 0. And this is going to be -2. So basically my factors are right here. So I'm going to have, I have all my factors listed right here. So my 3 factors are x minus 1/2, x minus 3, and x plus 2. And then we're going to multiply that by 2 because there's a factor of 2 there. So this is factored. That's what that polynomial factors into. So this polynomial up here, 2x cubed minus 3x squared minus 11x plus 6 factors into these 3 factors. And the fourth one is constant. Okay, so the other 2 zeros here are going to be 3 and -2. All right, moving on. Synthetic division, this is the last thing. Now synthetic division is a quicker way to do division. We just deal with the coefficients of the numbers to deal with this. Now we put in this method, we put in a little box here, the 0 for this, for the divisor. The 0 for the divisor is going to be 3. 3 minus 3 is 0. And then we write down the coefficients in order here. So we have 4x cubes. We don't have any x squareds. We have 2 x's and then we have 3 constants. So this represents 4x cubed, x cubed, x squareds, x's, and constants. Okay, the process is we draw a line. We bring down the first value. Okay, 4. We multiply by the box. We put the answer to that in the next column and we add these two together. So we get 12. Multiply again, 36. Add 38. Multiply again. 8 has 24. 9 has 114. And then we add, we get 111. So this is our remainder. So in this case, we're adding when we go down, and we're multiplying and put the answer next to this. So the answer to this problem is 4x squared, because we started with x cubed, so it's going to be 1 less, 4x squared, 12x plus 38 plus 111 over what we're dividing by, x minus 3. So this is a quick way to do that. We can do anytime we can only use synthetic division though if we're dividing by x plus or minus a constant. We cannot use synthetic division unless you're doing that. So all the ones I showed you at the beginning, we couldn't do synthetic division on this one because it has an x squared. We couldn't do synthetic division on this one because it has an x squared. But we can use synthetic division on, we could use synthetic division on this one. If I wanted to do this one by synthetic division, I could. I can do this one by synthetic division. So these two on the previous page, we can use synthetic division to divide them. So let's try that and see if we get the same answer. So 4x squared plus minus 3x minus 1 divided by x plus 2. Okay. Four x squared minus 3x minus 1 divided by x minus 3. I believe, let's just double check again, x plus 2. X plus 2. Wasn't close. All right, so okay, if we divide that by synthetic division, we put in a -2 here because that's the root of this one. We put 4, -3, and -1. We don't have any missing ones. 2, x squared, x, and constant. All right, and then we draw our line, bring down the 4, multiply, -8. We add -11, multiply, 22, add, we get 21. So our remainder was 21. Let's just double check to make sure that's what we got on the previous one. Yep, 21. Okay, so that worked out. I didn't have to do very long to do that, but I still got the same answer. Now we can also divide this one and get the answer. Let's see, you got to divide by 1/2. Okay, so if I was doing this by synthetic division, let's put it on this page. So I'm going to put in the 1/2 because that's my factor. 2x cubed, so that means I have a 2. 2x cubed. X squareds, I have -3. And x's, I have -11. And constants, I have +6. All right, so I'm going to divide this out. And we will see. Bring down the 2. Multiply, we get 1. Add, we get -2. Multiply, we get -1. Add, we get -12. Multiply, we get -6. And we add, we get 0. So this was x cubes. So this is x squared. X's and the constant. So 2x squared minus 2x minus 12 with a remainder of 0. It went in evenly. So, and then we can see that up here, we got the same answer by long division. 2x squared minus 2x minus 12, and it took us a lot less time to do synthetic division. All right, so that's this section. Long division, synthetic division. We have to do long division because we can't use synthetic on everything. Remainder theorem and factor theorem.